Good afternoon, class. We are looking at chapter 2, linear and absolute and quadratic functions, and 2.4, absolute value functions. So we covered linear functions, graphs of linear functions, modeling with linear functions, now absolute value functions, and the objectives are graph an absolute value function, solve an absolute value equation, solve absolute value equations, solve absolute value inequalities involving less than or greater than or equal, less than or equal, solving absolute value inequalities involving greater than or equal, and solve equations of the form absolute value of ax plus b equals absolute value of cx plus d. Those are the objectives, everybody. Reminding everybody of linear functions and starting with slope. M is rise over run, delta y over delta x, which means change in y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Vertical lines are in the form x equals a with slope which is undefined with x-intercept a0 with no y-intercept. Horizontal lines are in the form of y equals b. Slope is 0. Y-intercept is 0b. There is no x-intercept. Lines are in the form of standard form, ax plus by equals c. Slope intercept form, if you solve for y, you get y equals mx plus b. Point slope form, y minus y1 equals m times x minus x sub 1. Two lines are parallel if they have equal slopes, m1 equals m2, but b1 is not equal to b2. And they are perpendicular lines if m1 is equal to negative 1 over m2 and m2 equals negative 1 over m1, or in short, their product is negative 1. Using the concept of average rate of change to identify linear functions. If you have 2 points on a curve and you connect them, you get what is called the secant line, and you can calculate the slope, which is known as the average rate of change. So average rate of change, the difference quotient, delta y over delta x, equals f of x sub 2 minus f of x sub 1 over x sub 2 minus x sub 1. If you look at the very first one, you're using x sub 1 and x sub 2. It's called the average rate of change of y or f of x with respect to x over the interval of x sub 1 to x sub 2, and can be interpreted as the slope of a secant line. And here's your secant line PQ. Any 2 points on the curve that you connect. Now, the way we write M sub PQ, that means the slope of this line, rise over run. You could go with that, or if you call this x sub 1, y sub 1, and this is x sub 2, y sub 2, we get to this one. And so if you call it b and f of b, you get to this one. Or if you ignore b and f of b, just go with a and x, you get this one. And if this distance is h, you get this one. Normally we use this one as the difference quotient. The point being, all of this of different writing of the same concept known as the average rate of change of y with respect to x, also known as a slope of a secant line. (2.4) absolute value function. Absolute value. The absolute value of a number x, symbolized by the absolute value of x, is the distance x is from 0 on the number line. The absolute value of every number will be either 0 or positive. So when we say absolute value of x equals a, if a is positive, x is either a. or negative a. In other words, x is plus minus a. And if it's negative, it has no solutions. If it's zero, it has one solution, which is zero. For example, absolute value of 3 is 3, so is absolute value of negative 3, because as we look at the number line, by definition is distance from 0. So 3 units to the right, 3 units to the left, and that gives us two numbers, positive 3 as well as negative 3. For example, what is absolute value? If absolute value of x equals 2, what is the value of x? Well, there are two values, plus, minus 2. So the solution set is negative 2 and positive 2. Very straightforward. Solve the absolute value of 2x plus 1 equals 5. So here's the process. The absolute value principle for equations. For any positive number k and any algebraic expression x, the absolute value of the solution of absolute value of x equals k are those numbers satisfying x equals minus k or x equals k. The equation of absolute value of x equals 0 is equivalent to equation x equal to 0. The equation of absolute value of x equals minus k has no solution. We are assuming that k is positive, remember that. So because it's 5, then it has, you can drop the absolute value and say 2x plus 1 is positive 5, 2x plus 1 is negative 5, and solve those two equations. We are going to move the 1, and we get 2x equals minus 6 or 2x equals 4. And divide by 2, x is negative 3, or x is 2, and here's the solution set, negative 3 comma 2. You should always check to be on the safe side. So checking takes place with the original equation only. So I'm going to check one of them. I highly recommend you do the second one. So I'm going to check negative 3. So I'm going to write 2 times the absolute value of negative times the value negative 3 plus 1. The entire thing in an absolute value is this. I'm going to put a question mark equal to 5. That's how I'm checking. As you can see inside the absolute value, this is minus 6 plus 1. Absolute value of minus 5 is equal to 5. Yes. So it checks. And you can easily see if I put 2 here, 2 times 2, 4 plus 1 is 5. Absolute value of 5 is 5. So you must check. Absolute value of 3 minus 4x equals negative 10. It doesn't matter what expression you have here. The fact that this is negative means there is no solution. So this is phi, a Greek letter representing no solution. Okay, that in set theory means no solution. So this is the case here. So if you have the equality and you have a negative number for an absolute value equality, there is no solution. Again, if it's 0, there is one solution, you set equal to 0, and if it's positive, you have two solutions. Now, here's an example. We want to solve absolute value of 3x plus 4 plus 3 equals 11. In order to solve, we are going to take the following steps. Number 1, isolate the absolute value so that the equation is in the form of absolute value of x plus b equals c. If c is positive, proceed to step 2 and 3. If c is negative, the equation has no solutions. So it's important to understand what happens here. So that's the first step, everybody. And to do so, I'm going to move number 3. And because this is positive, we are going to move on. And we are going to separate the absolute value into 2 equations. X plus b equals c, x plus b equals minus c. That means drop the absolute value and say this is equal to -8. Drop the absolute value and say it's equal to +8 and solve. So the rest is very straightforward, everybody. We're going to drop the absolute value and once make it equal to 8 and once make it equal to -8. So we drop the absolute value and we made up 2 equations. And that's the idea, everybody. Make up 2 equations, and I can't emphasize this enough. And now we are going to solve and check. We are going to solve and check. So this one and this one, both of them move the 4 to the other side. The first one, 3x equals 4, and the second one, 3x equals -12. Divide by 3. X is 4/3, or x is -4. And as always, you must check, everybody. And checking takes place with the original equation. So I'm going to check one of them for you. If I check with -4, I get 3 times -4 plus 4 in an absolute value plus 3. And I'm going to put a question mark to see if it's equal to 11. So I'm going to simplify the left side. So 3 times -4 is -12 plus 4 plus 3. And this is -8 plus 3, which makes it 8 plus 3. Yes, it's equal to 11. I just checked for one of them. You must check the second one. Both must be checked and must be checked with the original equation only. Nothing in between. What about inequalities? If absolute value of x is less than a and a is a positive value, a is larger than 0, then x is sandwiched between -a and a. If you think of absolute value of x equals, let's say, 2, this is 2, this is -2. So it has 2 answers. If you think of absolute value of x less than 2, what does it mean? We are looking for points whose distance from 0 is less than 2. That means anywhere here. If you pick any number between 0 and 2, the distance is less than 2. If you pick any number here between -2 and 0, is the same thing. So that means x is sandwiched between the two. In fact, let's look at absolute value of x larger than 2. If I look at, let me look at here, absolute value of x larger than 2. That means anything beyond 2, the distance is more than 2. And anything beyond -2, so that means x is less than -2 or x is larger than 2. This is the justification for all of the above. The equality with a simple example. We showed that it's plus minus 2, less than its sandwich in between and greater than its beyond. So for now, we want to solve this absolute value of x less than 3. Then it's sandwiched between negative and positive 3, x such that x is between -3 and 3. And that's the solution set in the inequality format on a number line anywhere between -3 and 3. Are those numbers included? No. Since we don't have the equality, the endpoints are not included. If we had equality, then it would become bracket. Or there is another way of writing open. You may write it in this format. You have an open here and open here. But if absolute value of x if absolute value of x is less than or equal to 3, then this becomes bracket and this becomes closed, okay? The endpoints are included. However, going back to what we had, the interval notation would be this, -3 to 3, parentheses, because the endpoints are not included because originally we don't have a equality here. Let me clean up so we can see how this thing works. Same thing as this one here, we are going to have this sandwiched between negative and positive 5. And now we are going to add 3 to all sides, all 3 sides. We get -2 less than 2x less than 8. We are going to divide every side by number 2. When we divide by a positive number, the sign remains unchanged. If you divide or multiply by a negative number, it flips over. Be careful with that. So we get -1 less than x less than 4. So that is the solution set. X is between -1 and +4. If we were to graph this on a number line, and this is 0, we would say -1, we put a hole here, 1, 2, 3, 4, we put a hole here and everything in between. That's one way to write it, or we put parentheses. And interval notation, -1 to 4, this is interval notation, okay? All right, let's continue on that thoughts. Absolute value of 3x plus 7 less than or equal to 8. So we are going to write it as this expression sandwiched between negative and positive 8. Removing the 7, meaning -7 is added to all three sides. So -15 less than or equal to 3x less than or equal to 1. You're going to divide this one by 3. That means you're going to divide this one by 3 and you get -1, -5, and this one you get 1/3. So x is sandwiched between -5 and 1/3. Now, you don't have to write this because this is really the answer, but in case. This is a set builder notation, by the way. Set solution set is this is called set builder notation. Okay. Now, if we want to graph it on a number line, it goes from -5 to 1/3 somewhere here. This is not too scary. Yeah, it is here. Notice we are using brackets because the endpoints are included because we have the equality. Interval notation, just brackets from -5 to 1/3. Part B, absolute value of 2x minus 3 plus 8 equal less than 5. The inequality follows the same format as inequality, meaning the very first step is to isolate the absolute value. Whether it's a equality or inequality makes no difference. So the first step is to move the 8. And subtract from both sides. In which case gives you absolute value of 2x minus 3 is less than -3. There is no solution. Why is that? Because this is negative. We are saying absolute value is less than a negative number. It will never happen. Absolute value in the worst case scenario is 0. So because this is negative, it has no solutions. Phi stands for no solutions because this is negative. So step 1, isolate. Step 2, because the right side is a negative value, there is nothing else you can do. No solutions. And we're done. Absolute value inequalities of the form absolute value of x larger than a, and I showed you with that example of absolute value of x equals to. If absolute value of x is larger than a and a is positive, then x is less than minus a or x is larger than a. We've gone over that with a simple example of true. And so with that being the case, we want to solve the inequality of absolute value of x plus 7 is larger than 5. That means either x plus 7 is less than -5 or larger than 5. In other words, this one you just drop the absolute value. Or you say it's less than and you make this minus 5. Please understand you can't sandwich in between the two because that doesn't mean anything. We're going to move the 7 in both cases, resulting in x being less than negative 12 here, larger than negative 2. So that is the solution, the inequality solution. On a number line, you locate negative 12 and you locate negative 2. You use either a whole or parentheses. To the left of negative 12, to the right of negative 2 is shaded, if you will, or highlighted. As far as the set builder is concerned, just put that in brackets, braces, and write x such that x is less than negative 12 or x is larger than negative 2. The interval notation, we go from negative infinity to negative 12 union negative 2 to infinity. And again, don't mix it up with the less than, which is intersection of events. So two different things, we don't want to mix them up. All right, we want to solve this inequality. The absolute value of 4x plus 7 minus 9 is larger than negative 12. Remember, the very first step is to isolate, which means the very first step before touching the absolute value. Don't do anything to the absolute value. Move this. Isolate the absolute value first. Now, pay attention to the fact that this says the absolute value of 4x plus 7 is larger than negative 3. Pay attention that this is larger than. And the answer is that's a true statement. An absolute value, worst case scenario, becomes 0, and even 0 is larger than negative 3. So if you have any number that is negative and this is larger, that means all real numbers, x such that x is a real number, or we use capital R. So all real numbers would be the answer. Yes, it works always, no matter what. And that's the idea. So if I want to go with interval notation, from negative to positive infinity. If I want to go with a number line, I got to shade the entire or highlight the entire number line, and we're done. Part B, the absolute value of 6x minus 8 plus 5 is less than 3. So pay attention to the fact that this was greater than, this is less than. So first step, the same as this one, is isolation, which means we are going to move positive 5. And when we do that, the right side becomes negative 2. And now, this one, all real numbers, because absolute value is greater than a negative number. This one, no solutions. Absolute value less than a negative number. It will never happen. There is no solution. The solution is the empty set, or phi, a Greek letter, which represents an empty set. So I put the two questions next to each other so you can compare and contrast. So one more time, pay attention to this one versus this one. Both of them have a negative number on the right side. Is the absolute value greater than a negative number? Always. Is the absolute value less than a negative number? Never, ever. So distinguish between the two answers. Solving equations in the form of absolute value of x plus b equals absolute value of cx plus d. To solve an equation in this format, separate the absolute value equation into two equations as follows. Drop the absolute value. And the second one, drop the absolute value and put a negative sign in front of one side, not both. Any of them will do the job. And of course, solve both equations. So in order to solve this, one is just to drop the absolute value. So solve the inequality, the absolute value of x plus 3 equals absolute value of 2x minus 7. So the methodology is, one is just drop the absolute value from both sides. The second method is drop the absolute value from both sides, put one side in a parentheses, and put a negative in front of it. So this one is dropping the absolute value. This one, we drop the absolute value and we put a negative sign in front of one side. Now we are going to solve both equations. So starting with this, obviously I can move the x to the other side and minus 7 to this side. So when I do this one, I get 3 equals x minus 7. When I move the x and negative 7 simultaneously, I get x equals 10. So it's pretty straightforward, everybody. So I hope everybody can see that what happened. Basically, move things around, move so that x is on one side, number is on one side, and we're done. Let's look at this one, and we have to apply the negative. We make it minus 2x plus 7. And now when we move things around, if I move this here, I'm going to have plus 2x. That means 3x. If I move this one, 7 minus 3 is 4. And divide by 3. And here's your answer. So there are two answers. Either x is 10 or 4/3. As always, you should check. Checking takes place with the original. And I'm going to check one of them. So I can check 4/3. So if I put absolute value of x, which is 4/3 plus 3, and I'm going to put a question mark at top of the equality sign because I'm checking 2 times 4/3 minus 7. So if you look at the left side, the absolute value, 3 times 3, 9 and 4. So the left side is this absolute value. And the right side, 2 times 3, 6 and 4, 10/3 minus 7 in absolute value. Okay. And so 7 times 3, 21. 10 minus 21. This is minus 13 over 3 in an absolute value. That's the left side. This is the right side. And as you can see, both sides are equal to 13/3, and it checks. I pick the fraction because sometimes students seem to have difficulty with fractions. So yes, it works, and you can put number 10. 10 is easy to see. 10 and 3 is 13. So that's absolute value of 13, which is 13. 2 times 10, 20 minus 7 is 13, the same thing. So 10 is easy to see. I hope everybody's fine with that. It's pretty straightforward, as I said. Let's look at one more example. The methodology is that you drop the absolute value. Once you just drop it, end of the story. The second time, you drop it and you put a negative sign in front of one side. Which side makes no difference. So you drop the absolute value. That's one way. The other one, you drop it and you put a negative sign in front of one side, for example, the right side. Now let's work this out. Which means we are moving this one to this side. We make it plus 5. And let's move it the other way around. It's because 4x, let's just keep it positive. If I move this one this way, we get minus 3x. They add up to x. If I move this one this way, minus 8. And I have the answer. X is negative 13 in one shot. Just, I'm assuming everybody knows what I did. I'm going to go over that one more time. Move the 3x here. Negative 3x and 4x is x. Move the 8 here. 8 becomes negative 8 and negative 5 is negative 13. And you're done. It's that simple, everybody. Or you can do it in two shots. Move the 8, you get negative 13. Move the 3x now. If you want to do it in two shots. Anyways, this is done. Let's look at the second case. To do the second case, we are going to distribute the negative first. We get minus 8 minus 4x. And now if I move this one, I get 7x. If I move this one, get plus 5 with negative 8 is negative 3. And finally, I'm going to divide by 7. And now I have this answer. So there are two answers, negative 13 and negative 3 over 7. There are two answers. And I'm going to leave it for you to check it out. Let me check one of them for you again. Let's check the fraction. So 3 times x or minus 3 over 7 minus 5 in an absolute value. It's equal to 8 plus 4 times negative 3 over 7. So left side is negative 9 over 7 minus 5. Let's work on this. 5 times 7, 35. Minus 44 over 7. This one we have 8 minus 12 over 7. 8 times 7, 56 minus 12, also 44 over 7. As you can see, both of them end up being 44 over 7. The absolute value of negative 44 over 7 and the absolute value of 44 over 7, both of them are the same. So it checks with the original equation. You should only and always check with the original equation, and I'm going to assume you can easily do negative 13 as well. It's very simple. Here's the summary for absolute value equations and inequalities. To solve inequalities of the form absolute value of x less than 0, absolute value of x less than or equal to 0, absolute value of x greater than 0, or absolute value of x greater than or equal to 0. By the way, the equality, you just keep the equality. Okay. So the absolute value of x minus 5 less than 0, because it's less than 0, has no solution. The absolute value can never be less than 0. If it's less than or equal to 0, then because of the equality, it can be set this equal to 0 and you get 5. The absolute value of a number can never be less than 0, but it can be 0. Absolute value of x minus 5 larger than 0. It's always larger than 0, except at 5 becomes equal to 0. So substituting any real number x except for 5 makes it positive. Absolute value of x minus 5 greater than or equal to 0. Because we have the equality, any real numbers you pick is either 0 or greater than equal to 0. So the absolute value of any number is always greater than or equal to 0. So this is the synopsis that would be helpful. So I hope everybody's fine with that. And we are going to move on. Reminding you of what we did with the absolute value equations and inequalities. We've done that. So just to remind you again, absolute value of x by definition is distance from 0. Therefore, it's either x when x is greater than or equal to 0 or minus x if x is less than 0. And for that reason, if you have a function of x, the absolute value of function of x is the same thing. F of x is f of x greater than or equal to 0, and minus f of x is if f of x is less than 0. So, and again, these are the inequalities. Absolute value of x equals a. We have two answers, plus minus a. If it's less than a and a is positive, it's between negative a and a. If it's absolute value of x larger than a and a is positive, x is either less than minus a or larger than a. And if you look at the graph of the function, looks like a V shape. Domain is all real numbers. It covers all the x-axis, the range from 0 to infinity. And this is just to remind everybody of what we have done. So we're going to look at a couple of questions we have seen. So determine the function obtained from a series of transformation on y equals absolute value of x. So we know this is the shape, a V shape. Absolute value of x plus 2, that means shifted left by 2 units. So we are going to, the vertex is originally located at 0, 0, and it's going to move to here, and it becomes negative 2, 0. That's as far as the location of a vertex. Shift up by 3 units. Now we're going to take this up by 1, 2, 3 units. And so the vertex was 0, 0, then negative 2, 0, and now it goes to negative 2, positive 3. And then reflected about the y-axis. So we change the x to minus x plus 2 plus 3. And the graph, which was the green one, with respect to the y-axis, it's been reflected, creating the red one. So the same distance here. So the height of 3 for the vertex doesn't change, but negative 2 changes to 2. And one way to understand this, alternatively, we look at this one and say absolute value of minus x plus 2 plus 3. If you take the negative out, we get absolute value of negative 1 times x minus 2 plus 3. And this absolute value of negative 1 is the same as positive 1. And this shows shifted to the right by 2, up by 3 units. And let's see, what color do we want to use? This is the new location of the vertex, which is 2, comma 3. Graph functions using compression and stretches use the graph of f of x equals absolute value of x to obtain the graph of g of x equals to absolute value of x. So basically, we know that if we choose a few numbers for absolute value of x, we get the same values, all of them positive. So this becomes 3, 2, 1. This remains unchanged. They remain unchanged. Okay, so that's something we know. Now, if we want 2 times absolute value of x, so this column, the second column, we're going to multiply it by 3. So it becomes 6, 4, 2, 0, 2, 4, 6. And if you plot those pairs, well, that was the basic y equals absolute value of x. But now 1, 1 becomes, if you look at 1, 1 now becomes 1, 2. Okay. 2, 2 becomes 2, 4. 0, 0 doesn't change. And negative 2, 2 becomes negative 2, 4. Negative 1, 1 becomes negative 1, 2. So it gets closer and closer to the y-axis when you multiply it by a number larger than 1. If you multiply it by a number that is a fraction of that, for example, 1/2, as we are going to do here, so this gets closer to the y-axis, this becomes sluggish and gets closer to the x-axis. So again, we have the first two just as this one doesn't change. Now we want half of this. We divide the second column, which represents the y coordinate, by half for this one. So for half of absolute value of x, this becomes 3 halves, 1, 1/2, 0, 1/2, 1, 3 halves. And so if you look at this function, 0, 0 doesn't change, but 2, 2, the 2 remains, and the y coordinate, half of that is 1. And negative 2, 2, again, negative 2 remains 2, half of that is 1, so it becomes closer to the x-axis. This one gets closer to the y-axis. This one gets closer to the x-axis. It's sluggish. Just to give you an idea how the graph will work. All right, transformation of functions. We want to sketch the graph. We had done this before, so we are going to remind you how it's done. Number one, we should know y equals square root of x. It looks like this. We are going to graph this without paying any attention to the absolute value. So we are graphing square root of x minus 1, which means this one shifts down by 1 unit because it's negative. So the same thing, bring it down by 1 unit. So 0, 0, for example, becomes 0, negative 1. Notice, move it down by 1 unit. Same graph, bring it down. So 0, 0. 0, 0. Now it's 0, negative 1. 1, 1. Is 1, 0 as an example. So that's it. Now, absolute value, here's how it works as far as the absolute value is concerned. Graph the part of the graph of the f of x that lies above the x-axis remains the same. So this portion doesn't change, everybody. This doesn't change. The part that lies below the x-axis is reflected about the x-axis. So what happens to this part flips over. So this part flips over with respect to the x-axis, and it looks like that. So 0, -1 as a location, new location, 0, +1. That's how you do the transformation. I hope everybody remembers it from previous sessions we went over that.